So what are a couple ways that we can use a diagram to represent what's happening in an ionic bond? Well, one way to do that is by using the concepts of the quantum model. So here are a few steps we're going to follow for showing how to represent an ionic bond using the quantum model. So the first thing is to determine the formula for the product using the ions that would form, determined by the family that they would be found in. So sodium is in family 1. Everything in family 1 would form a positive 1 charged ion. Chlorine is in family 7. Everything in family 7 will form a negative 1 charged ion. So by doing our ion quizzes here, combining an Na plus and a Cl minus will give us NaCl. So then, second step, show the electron configurations for the atoms in the formula of the product, but only show the valence electrons. Okay, so sodium has 11 protons, and in this isotope it has 12 neutrons. So we also have 11 electrons we have to assign. So 1s2, 2s2, 2p6, that's 10 electrons. And then we have one more in the 3s orbital. So now we're going to represent that one valence electron in the 3s orbital by drawing it into our orbital representation. Chlorine has 17 protons. This particular isotope of chlorine has 18 neutrons. Well, we have 17 electrons we have to assign. So 1s2, 2s2, 2p6, that gets rid of 10 electrons, and then two more in the 3s, and so we only have 5 electrons remaining, so it'd be 3p5. Now the valence shell is 3, so we're only going to show the electrons in the valence shell. The 3s orbital would have up arrow, down arrow, and then the p orbitals, px, py, pz, for the third energy level, will have up arrow, up arrow, up arrow, and then down arrow to represent the 5 electrons. So with this quantum model, you can see how the electrons are going to transfer and how the result is 2 full valence shells for each atom. So sodium is going to transfer its 1 valence electron to chlorine. And so the result is what we'll draw over here. We'll draw the sodium ion electron configuration. Still 11 protons and 12 neutrons, but now our electron configuration is 1s2, 2s2, 2p6, and we have an outermost shell for this ion of n equals 2, and n equals 2 is completely full, a full outer shell of electrons. Chlorine is the same way, 17 protons, 18 neutrons, but now for the chloride ion, we have a completely filled third energy level, a completely filled valence shell, because the 3s orbital now has 2 electrons, and the 3p orbital is now completely full as well with 6 electrons. That results in an additional electron, which gives the ion that negative charge. But now both substances have complete outer shells of electrons, which is what atoms are trying to accomplish when they form bonds with other atoms. Now we can also represent this using the Electron Dot Method. So if we follow these steps, we can make a diagram that represents the formation of an ionic bond using the Electron Dot model. So determine the formula for the product the same way we did before. Sodium is in family 1, so that's Na+. Chlorine is in family 7, so the ion would be Cl-. Everything in family 1 forms a +1 ion. Everything in family 7 forms a -1 ion. So the formula would be NaCl. So then let's draw the electron dot for sodium. Now we only have one sodium atom, so I'm only going to draw the electron dot with one sodium atom. It's pretty easy, just one dot. Then chlorine. Chlorine is in family 7. It has 7 valence electrons. So represent that by drawing your electron dot for chlorine. So now it's pretty easy using the electron dots to see what's going to happen. That one sodium electron is going to be transferred to the chlorine, and that leaves sodium as just simply Na+. And chlorine now has gained that electron, which we will represent the gaining of that electron with a red dot, and now it is Cl-. So we've represented the formation of an ionic bond using the electron dots. Let's try it for potassium and selenium. Well, potassium is in family number 1, so it forms a +1 charged ion. Selenium is in family 6, so it forms a -2 charged ion. So the formula for our product will be K2Se. So we need to represent 2 potassiums, each with 1 electron as its electron dot structure, and then selenium with 6 electrons around it. And once again, it should be easy to see what's going to happen. Selenium needs 2 electrons, and each potassium has 1 electron to give. So the electrons will be transferred from the potassium atoms to the selenium atom to form our ionic compound. So we're going to alternate ions here. We're going to start with K, and then Se, and then K again. Both K atoms have lost their valence electrons, so they're just going to be represented with the plus sign. Now selenium has picked up or gained those 2 electrons from the potassium, so we're going to draw the electron dot structure for the selenium ion, which shows those 2 electrons from the potassium as dots, and then we label it 2-. How about another one? So magnesium is in family number 2, so it forms a +2 charge. Nitrogen is in family 5, so it forms a -3 charge. So the formula for magnesium nitride would be Mg3N2. So now I have to draw 3 magnesiums, each with 2 valence electrons drawn as dots. And I need to draw 2 nitrogen electron dot structures, so they need 5 electrons around them. And we can see that to complete this compound, each nitrogen needs 3 more electrons, and we have 6 electrons from magnesium that can be transferred. So we just have to show the transfer of electrons to these different positions in the nitrogen atoms. And the nitrogens are going to gain the 3 electrons. The magnesiums are going to lose their 2 electrons. So when we draw this as a compound, we're going to alternate magnesium, nitrogen, magnesium, nitrogen, magnesium. The magnesium atoms have become cations, so we'll represent those with just 2+ charges. The nitrogens have gained 3 electrons. The electrons they've gained will represent as dots, and they will have a -3 charge. And that just repeats down the line here to make the compound magnesium nitride. All right, why not? One more. So we have neon and chlorine. What will the electron dot structure for this compound look like? Well, neon is in family number 8. It's a noble gas. It doesn't form ions. This is going to be no reaction. Neon is unreactive because it already has a full valence shell. It's not going to do any bonding because it doesn't need to.